Hello friends, welcome to 10 Min Lectures YouTube channel. Today we'll be continuing second lecture on the number system. The previous class we had discussed about what is number system is, what are the basics, and the conversion from decimal to various other number systems. Today we'll be going through what a binary is and we'll be proceeding with the conversion based on binary. So at first let us see what is a binary number system. A binary number system consists of only zeros and ones, as we all know. Now, what is zero? This is the basic thing that many of the students don't know. Zero is something that represents a low signal. The low signal is represented with the help of voltage that a node receives, or the circuit which is implementing some data manipulation. So as an input, if the voltage is low, it is represented using 0, and if the voltage is high, it is represented using 1. Now, as we all know, computer is just a machine. It can just understand the presence and absence of a voltage, as 1 represents the presence of voltage and 0 represents the absence of voltage. Now it can be 0 voltage for 0 and 5 volt for 1, or it can be some variation in voltage, let's say 1 to 3 voltage for 0 and 6 to 7 voltage for 1, and rest all voltages are ignored by the system. This is just the basic that variation in voltage is represented using 0 and 1. Okay, so this is a binary language. Coming back to our topic, today we'll be learning how to convert binary into decimal. So let us consider this as our input 1011, and it is represented using the base of 2, which tells us that the given number is in binary. It is not decimal. It is not 1011. It is 1011 binary. So to convert from binary to decimal, what we'll be doing is we'll be taking each of these digits and multiplying it with the corresponding power of 2. Okay, I know it will be a bit of confusion for you. We'll work it out. So what we'll be doing is we'll be taking each digit, and with the first digit here we'll be multiplying it with the 2 power 0 by 2, because this is binary. Okay, so since this number is in binary, we'll be using 2, and this first position is represented using 0. Now when we come to the second position, we'll be multiplying it with 2 power 1. When we'll be coming to third position, we'll be multiplying it with 2 power 2, so on and so forth. So we'll be taking each digit and we'll be multiplying it with the corresponding power of 2. Okay, so what is 2 power 0? Anything power 0 is 1. So 1 into 1 will be getting a resultant of 1. 2 power 1 is 2. 2 into 1 is 2. 2 power 2 is 4. But anything multiplied by 0 is 0. So we'll not be considering that. 2 cube is 8. 8 into 1, 8. So what we'll be doing is we'll be just adding all these things, and the resultant will be our decimal, that is 11. So the decimal representation of 1011 in binary is 11. So I hope it is clear. So what we'll be doing is we'll be taking each digit of binary and we'll be multiplying it with the corresponding power of 2. Okay, that's simple conversion of binary to decimal. Next is binary to octal. Here what we'll be doing is we have taken a bit longer string here so as to explain the things more elaborately. So what we'll be doing is we'll be just splitting this given string with a set of 3 digits from left to right. Okay, so we'll be splitting it in this way: 3 digits here, 3 digits again, and let's rest is remaining. So it doesn't matter if here is 2 more zeros, so it doesn't make a sense. So 3 digits here as well. So what we'll be doing is Now this is the rule that I just explained. Split the given binary digit into n number of sets of 3 digits each from left hand side. Okay, so from left hand side you have to split it. So it will be the same thing. I brought a gap here to represent that these three are three different sets. We have splitted it. Now what we'll be doing is we'll be using this table, and with the help of this table we know this basic conversion. This is you can say this 0 to 7 as octal or decimal, because both the conversion are similar as far as binary is concerned. So in our previous class we have discussed how to convert a decimal digit up to 7 to binary. So this table you must be knowing. If you don't know, please go back to the previous video and it has been explained there. So let's take one each set one by one. So 001, what's the corresponding number? It's 1. So we have written 1. 011, what is corresponding number? 3. So we have written here 3. 110, what is corresponding number? 6. So we have written here 6. So 136, that is 136 is the corresponding octal number for the binary 1011110. Okay, so this is the simple method. Just split it into a set which contains 3 digits each from the left hand side, and you have to just look into this translation table, and you have to just put the corresponding numbers here. So here we have put 8 as a base because this is octal. Okay, next one is binary to hexadecimal. We have taken the same number as we have taken for octal for binary to octal conversion. Okay, here also the concept is the same, but what you have to do is we have to split it into 4. Why 4? Because hexadecimal consists of 16 as a base, right? Now 16 base consists of 4 digits, that is, this is 15, that is 0 to 15, right? So 4 digits are here in hexadecimal. In octal there were 3 digits because 111, this consists of 7, that is 0 to 7. 0 to 7 consists of 8 digits, right? So this is for octal and this is for hexadecimal. Okay, so what we'll be doing is we'll be just splitting it into digits of 4 in each set from left hand side. So this will be our resultant. Now same thing what we have done in octal, we'll be taking the corresponding number 5, and this is 14. 4 ones means it is 15, so just 1 is reduced here, so it is 14. Now as we all know, in hexadecimal there is no digit named 14, there is only alphabet, right? E. So 5E. So 5 is SH because 0 to 9 in hexadecimal is the same. Alphabets are used from 10 to 15, so that is E to F. So 14 corresponding is E. So 5E is the representation in hexadecimal. 16 represents that this notation is in hexadecimal. So that's it. So here's an exercise. Please try it by your own, and if possible, if you have any comments, please give it below. And that's it for today. Thank you. And in case if you have any queries, you can always mail me at 10class@gmail.com. If you like this video, please like and don't forget to subscribe our channel. Thank you.